Hello again. It's me, Joe Clark, and this is a continuation of my last episode where I did a walkthrough of the upgrade to CML 2.10. And I threatened I would do a walkthrough of some of the new features because this is quite an impressive release. I'm really excited for the team. They did a great job, and there's some cool things, some actually really innovative things that I think you'll enjoy. So let's get right to it. We'll start with one of the smaller features, smaller new features. But before I go, I did the upgrade walkthrough of my cluster, my 3-node cluster. Whereas this is my home installation. This is just a standalone version, but it doesn't really matter. The features we're going to go through today work whether or not you have CML Enterprise or you have CML Personal. There is another feature which I'm not going to show today, which is radius authentication into CML. It's there. It's part of 210. It is labeled experimental, so you have to turn it on, but that is only available to CML Enterprise and Education. So what I'm going to go through would work in any deployment of CML. So first, smaller feature, and that is custom icon support for node definitions. So let's take a look at that. I'm going to go to the Tools menu here and select Node and Image Definitions. And I'm going to go down to Nginx since I happen to pull this icon. You can see I've already got it here. So by default, all of these icons are relatively general or generic. They're the ones that have been included with CML since CML 2.0 came out. But in 2.10, you have the ability at the node definition level. So not at the instance, unfortunately, but at the node definition level, you can change the icon to essentially whatever you want. So I've done this here with Nginx. So you'll go to the node definition. You may have to mark it as not read-only. By default, all or many at least of the system provided node definitions are marked read-only, so just set that to not read-only, and then come down here to user interface, and here you'll see the icon. By default, it's going to be one of these, so it would probably look something like this. I'll go ahead and update that so you can see what that looks like. I'll go back, come down to Nginx. Again, you can see it looks just like any of these others, generic icon. So we're back in the node definition. We come here to user interface, we select icon, and we scroll all the way to the bottom, and you'll see custom. And custom icon comes up, and you have two options. The easier of the two options is just to pick an image from a file. Great. However, if you have memorized the base 64 encoding of your icon, you can paste that in as well. But we're going to just do the easy one. So I'll click here, find my icon. I've saved my Nginx logo. You can see it looks very nice. It's transparent. I found the transparent PNG out there. I click update, go back. Now we'll see that it shows up here as the Nginx custom icon, and I'll come over to one of my labs. I don't actually have any images loaded for Nginx, so I had to select this option up at the top. You can see in the picker, it is still the custom icon, and when you add it to the topology, it's still the custom icon. So you get that icon all the way through, but this means that all your Nginx instances in this example will have that icon. This does stay with the node definition, but obviously if someone else has a different node definition without the custom icon and you share your topology with them, they're not going to see this. I'll go ahead and delete that. So that's the first feature, custom icons. Second feature is Lab autostart. This is something that several users have asked for over the years, and we now have this baked in. So if you go to one of your labs that you like, you can go to the lab option at the top and select the auto start and then just enable that and give it a priority. When you click on the field, it will say labs with a higher priority will be started sooner. So you pick a high number and then you go down if you want to stagger when labs start. And this means that after CML reboots, it will start these labs that are marked as auto start automatically. This is great for just about any kind of multi-user situation where, for example, you're in a lab and you want every time CML starts, you want like, or in a classroom, I should say, you want the classes labs to start up automatically. You don't want to have to manually do that. That's great. If you're running a multi-user lab and every time CML restarts, you kind of want the company's main simulation or main lab to come up. This is a great feature for that. Don't forget to click the save button when you're done, and then that lab will be auto started. Related to that is this idea of node sequencing. So one of the things, just like Lab Auto Start, this is something that's kind of been requested, though maybe indirectly requested for a while now. You may have a lab that has several maybe bigger types of nodes, like your Catalyst 9kV, even Catalyst 8kV or Nexus 9kV, and you don't want them to all start right at the same time. But there are some nodes that need to start before others. They're like, if you think of a multi-tiered network, maybe you want your edge to start first and then your core, and then you want your distribution and access layers to come up. Well, with node sequencing, you can decide how those nodes are started. So what we can do, click on a node, and you'll see that there's this new section here, the node details pane for node staging. And this has a priority just like Lab Auto Start does. The higher the priority, the sooner the node will be started. So I could do something like my router 1 here, I want that to have a priority of 100. My node 2, or router 2, let's say, is 50. And then router 3 is 25. So these should start, and then there's also this other option here for node staging where you want to turn this on, and then what you want to do. So enable priorities on nodes will be respected. So this is, make sure you do this, or we set the priority, but nothing's going to happen. And then there's this option abort on failure. So if enabled, no nodes will be started if a higher priority node fails to start. So what does that mean? So coming back here, remember I gave a router 1 priority 100. That's the highest priority in this lab, 150, 25. So this says in the node staging, I didn't save it, but abort on failure. So if router 1 fails to start, router 2 and router 3 won't start. And so that it's not enabled by default, but in some cases you may want that. And then you have this. If enabled, even nodes with no priority will be started. So that's the start remaining nodes. So you noticed I didn't give any priority here to the external connector and the unmanaged switch. I could have other nodes in here. I really only care, let's say I really only cared about router 1, 2, and 3. Those needed to start in a specific order. The rest of the nodes can start in whatever order you want. You want that option selected then. So I'll go ahead and save it this time, and then we can confirm that it does in fact save. Yep, everything is enabled. Great. I'm going to go ahead and stop this lab. Okay, everything goes down. And when I stop it, you notice now that the priority tag or label appears on the node. So you can see visually what nodes have the higher priority. And remember, higher priority nodes will be started first. So we should expect router 1 to be the first node that starts up, followed by, once router 1 has come up, router 2 and router 3. So let's see if that happens. I'll go to lab, start lab, and see what gets green. So router 1 automatically goes green first because it has the higher priority. And this is an IOSV node, just to confirm IOSV. So this is going to take a little bit of time to start. We can watch the console here as it's coming up. So this is great because imagine if this IOSV is kind of small, but imagine if this was that Nexus 9kV or an XR 9kV, and you don't want what's known as the thundering herd problem, meaning you don't want a lot of nodes competing for those precious CPU cycles and RAM all at the same time. A lot of times these nodes, when they're up and they're running, they're fine. They don't take that many resources, especially CPU time. But when they're booting up, they spike. They go really high. So you can come over here to the nodes pane real quick, and you can see the router 1, it's booting, its CPU is really high. I don't want anything contending with that. I'd like router 1 to be able to fully boot up as quickly as it can, as I can make up a word stably as it can, as stable as possible, so that it reaches a good state quickly. When that happens, then okay, things have settled, we're good, let's move on to the next device. Again, I may not want that on all of my devices in a lab. It may only be certain, especially those higher end devices that take so many resources. Those may be the only ones I have to consider this for. And the rest I can put into that bucket of any priority, just start whenever the prioritized nodes have already gone. So I'm going to let this go for a little bit. We'll come back. Well, actually, let's see what happens with. Make sure router 2 gets to crank up before router 1. So I'll go ahead and kind of force it along here by going into the. See if I can get it to recognize that it's booted. It has to go. So see, it's still got the booting icon. It needs to go to the green check, and that will indicate that it's fully booted. Now, there's two things that can affect that. This happens to be an issue we've identified. The fact that IOSV doesn't, it should by now have already gone to the check. Um, but there's a timer as well. So usually these nodes have at least one, which is time, how maximum amount of time they'll wait before they'll just be considered booted. And there's others where it's looking at the console output to see if a certain prompt has been printed, and then it will say yes, it's booted. In this case, we've identified that we probably need to add another pattern to that to make sure that IOSV has properly booted. I can't add that right now because the node is already booted, but there, just went there, and you can see, went to check, green check, it's booted, and now you can see router 2 coming up. So it's following the priority order, 100, 50, 25. And then when all of these nodes are up, we should see these other two come up as well, and they can come up in any order. We're not going to wait for that. We're going to move on to the next feature. So that was node sequencing. Now, this next feature is near and dear to my heart because I contributed it. This is the Cisco, the CML Model Context Protocol Server, or MCP server. I've done several demos of this, so I'm not going to get too into it. The MCP server allows you to use natural language with the help of a large language model, so AI, yay, to interact with CML, to create labs, to run commands on labs, stop nodes, start nodes, all of that sort of thing you can do with natural language with a client like Claude Desktop or Cursor or VS Code. The MCP server is not enabled by default. So if I come over here to my cockpit on my home server, go to services, go here to services, and I do a search for MCP, you'll see, I've enabled mine, but you'll see that it is disabled by default. You want to enable it and make sure it starts and it's enabled. Then the MCP server is running, and you can use it will allow you then to do the natural language with it. The other thing you're going to want to do, or you can do, is go to Tools and MCP Clients, and this will generate a config snippet that you can put into your client, your Cursor, your Claude Desktop, so on and so forth, to enable you to connect to the MCP server, or enable your client to connect. And then you could do some really cool things. I have one thing that I've already done, so I'm not going to walk through all of that. Again, there are videos out there, demos that walk through more of this. But today I was just playing with this. So this is Cursor, so I'll bring it into view here. This lab behind me, the BGP Demo Init Lab, I said, you know what? I'd like to spin it up. So it did all of that. I'll show you that in a second. And then I said, I'm actually trying to learn BGP. What I'd love to see is the analysis of how BGP works. So go ahead and clear the BGP peering on router 1, on R1, and then run a packet capture, run a live packet capture of the BGP traffic and explain it to me, essentially. Give me an analysis of that. And it started to do that. So it runs these what are called tools on the MCP server. It did all of that. It started to explain how BGP works. And then I said, you know what? I'd really love to see this as a ladder diagram. And it generated this out as a full ladder diagram, so I could see that here's the teardown when I asked it to do the clear. Then it did the TCP handshake, the BGP open, sessions started to establish, and then route exchanges happened, and I can see the routes that were learned and the routes that were advertised. And then things moved into a stable keep alive state. So this is a great way not just of creating labs or having your intent or your imagination realized in CML. But this could be a way to help you better understand what's going on under the covers with some of these network protocols because it has the ability of doing things like packet captures and then analyzing. The LLM can then analyze those packet captures. So check that out more. Again, I really think that's a fairly cool feature available in all versions of CML. So we've gone through custom icon, lab auto start, node sequencing, talked a little bit about MCP. I'll bet my lab is still coming up. So yep, still coming up. Not to worry. The other really cool feature I want to talk about, something that I haven't seen anywhere else in terms of lab simulation. And hats off to CML team and especially Justin for creating this and realizing it. Um, more is coming, but I want to give you a little bit of a teaser. What's in CML 210 now, and that is wireless support. We've all been connecting wired interfaces, wired links. We've been connecting interfaces as gigabit. We've been doing link conditioning on them to make them look either lossy or just make them look slower. But we've never had a medium like wireless in a virtual environment like CML. But now we do. So in CML 210, it ships with two node definitions by default, a wireless client and a wireless AP. So I'm going to go ahead and add both of these to my topology, my lab here, and an external connector. I'm going to connect the external connector to my wireless AP on ENS2, the physical. So this is a physical connection right here. What I'm not doing is creating any physical link between my wireless client and my AP. That's what's really cool. Well, it's one of the things that's kind of cool about this. What's really cool is just the ability to test and learn about wireless with this feature. And I'll go ahead and crank this lab up. So I didn't add any auto start, or sorry, I didn't add any sequencing parameters to this, so it's just going to come up however it comes up. These are Ubuntu nodes, the wireless client and the wireless AP. So in CML 210, we're shipping general open source wireless with a host APD based access point and a WPA supplicant client. Take a look at the config really quick. So on the AP, you'll see that by default, there's just a basic Wi-Fi 802.11 config. That's deployed here, 2.4 gigahertz, channel 6, with an SSID of OpenAP. No password or anything like that, no WPA. You can configure all of that. I encourage you to look up the documentation for host APD, and you can configure all of this. The complementary config exists on the client, so it uses WPA supplicant on the client to associate to OpenAP, the OpenAP SSID with no security. Great, that's fantastic. Again, you can configure different parameters if you want. You can look up the documentation for WPA supplicant and the documentation for host APD. Okay, the lab has come up, and you notice two things here. One, everything's green, that's good. Two, each of these, well, you've noticed that before, each of these wireless clients have a special icon that indicates that they're wireless. But the most interesting thing is that there's this green link between the client and the AP. I didn't draw that. I drew this link. I added this link here between the external connector and the AP, but I didn't do anything here. And when we mouse over this link, we see wireless information. we see that it has a signal strength of negative 34 dBm. It's representing an association with the SSID OpenAP on a specific channel at a specific width. So this is channel Wi-Fi 2.4 gigahertz, Wi-Fi channel 6 at a 20 megahertz channel, and it's been connected for 83 seconds. So let's just take a look at some console output here. So I will look at IP link show. You can see that the WLAN 0 is in state up, so the wireless interface is in state up. That's good. And now let's take a look at IP adder show. We see we actually have an IP address. So this was a NAT-based external connector. So we get an IP address via DHCP through the wireless AP. Let's take a look at how the wireless AP is operating. Let's do IP link show. So IP link show says that ENS2 along with this WLAN 0, so ENS2 is the physical Ethernet interface, WLAN 0 is the Wi-Fi interface, the wireless interface. They're both in a bridge BR0 and BR0 is here. So they're bridged together. So we're not routing between them. We're bridging the DHCP from the external connector to our wireless client. Cool. So let's see if we actually can pass some traffic. Let's see if we can ping Google. We should be able to from our wireless client. So no wires, nothing up my sleeve. The traffic is flowing across this interface, this association, if you will. This is the air. This is just how wireless works. And so we can see that traffic is passing. Now, something really cool. Typically, when you draw your topology in CML, you're thinking logically. You're thinking what looks good and logical, easy to read for a human. The distance between nodes doesn't really have any meaning to it. It's just there for ease of readability or logical segmentation. In the wireless space, distance between your client and your AP matters. So if I take this client and I move it way over here, and we wait a few seconds, a minute or so, we'll notice something. We'll notice something very obvious. We can ping while we're doing it. We notice that the link turns yellow. Why did it turn yellow? Well, when we mouse over it, we see that the signal has gone from negative 34 dBm to negative 61 dBm. So we're actually getting a worse association because we're moving further away. So our signal becomes weaker and weaker as our client moves further away from the AP. And if I continue to separate these two, I'll move it out a little bit further, getting the client even further away, we'll see that the dBm, again, this takes a few seconds to update, but the dBm will drop again. Now it's dropped to negative 66, and you can continue to go further and further away until the client and the AP can no longer communicate. Now, one thing you will notice is if you try to right-click on this link, like you would on a physical link, nothing happens. You get only this mouse over, you don't get anything else. However, if you right-click on one of the nodes, I want to do that, I wanted to right-click on one of the nodes, you'll see that there's this new wireless option here. If you click on that, you can begin a wireless packet capture, and it will look at nodes sourced from the given device. So in this case, it's looking at nodes sourced from the wireless client. So there's not a lot there. There's the ICMP ping. We expect to see that. So this is like just doing a packet capture on the link, on a physical link. But when we do the same, I'll go stop this. When we do the same packet capture on the AP, we're going to see something very interesting. Since it's packets being originated from the AP, we see these 802.11 frames as well. And we can dig into that. So if I start this, I can look at, this is a beacon frame, and we can dig into that and look at how the wireless would actually look in the air if we were doing a wireless packet capture. So we have that capability of doing this. Remember, unlike physical links, we have to right-click on the device itself, and we'll only be able to look at packets originating or frames originating from that device. We're looking at how that can be changed so we can look more at the whole air, what's happening in the full airspace. But right now it's on a per node basis and packets from those devices. So that's the wireless feature. And the last thing I want to show you, it's similar to this, similar to the packet capture, but I'm going to go back to my other lab. Stop this one real quick. There we go. I'm going to go back here. This should all be started now. Good, everything's green, everything is fantastic. The last thing I want to show you is related to packet capture, and I think it's also a very cool feature. It needs the breakout tool, so be sure you go to Tools, Breakout Tool, and you download the latest breakout tool for CML 210. So you need the CML 210 breakout tool. So I've already got that loaded. I've got that loaded over here on my Mac. Got the breakout binary there, and I've pulled down my labs. And there's this new feature. So if I run breakout without any arguments, I'll see that there's this option here for, should be PCAP. It's not documented yet, but there is a hidden, I'll have to get that fixed. There is a hidden PCAP option. So there's config, init, run. Well, there is a new hidden PCAP option. So if I run it like that, it will connect to the controller and tells me, well, it doesn't look like you have any packet captures running. The other thing you need is in your config file for the breakout tool, you want to make sure that there is a Wireshark path here. So this is detected if you regenerate the config with the CML 210 version of the breakout tool. The Wireshark path will be automatically detected. But if it isn't, you'd have to add this. So what is the path to where Wireshark is installed? So this is where it's installed for me on my Mac. And again, when I run it with the PCAP option right now, nothing. I'm not running a packet capture. But let's say I go over here to this link between router 1 and router 2. I right click on it and I say packet capture. And then I'm going to do a start here. So it's running, that's fantastic. Packets will be going out. Then I come back and I run that same command, breakout tool with the PCAP argument. Then it's going to tell me, I found a running packet capture with this key. So I'm going to run again, breakout tool, PCAP argument, but now I'm going to add the key to the end of it. And this should launch Wireshark for me. There it goes. Wireshark is now running. And you can see the same packets that are being displayed here in CML are also being displayed now in Wireshark. This becomes much easier to analyze traffic and see what's going on and do some of the nice Wireshark things like follow TCP stream. As an example, let me go into the console here, enable myself, and do a clear IP BGP. I think I could do star. I cleared it. Go back over here to here, and we can see in Wireshark now that whole BGP thing that the MCP server showed, where we have the open messages come out, we have the update messages that are sharing the routing updates, so we can see all of that happening here. The network layer reachability information. We could do, like I said, the capture. I'll just do it from here. Go to one of these packets and say follow TCP stream. That's not terribly useful to us, but we get all of our BGP messages now all coming in that one TCP stream. We can look at all of that, and we can analyze this again with all of the Wireshark capabilities that we have. Much more convenient, even though you have the dissectors built into CML, this is much more convenient for doing that troubleshooting, especially during doing that learning and understanding what's happening with these protocols. So with that, those are the features I wanted to go over. I hope this has inspired you to go back and check out that upgrading video so that you get your own copy of CML 210 and you start labbing right away with all of these great features. Enjoy.